Okay, couple things to review here. Okay, first off, okay, in the mole equation looks like this: N equals little m over big M. And remember that N is the number of moles. Okay, little m is the mass in grams, and big M is the molar mass in grams per mole. And grams per mole, the molar mass, is what we get by adding the numbers from our periodic table together. Dominic. It's in the booklet, lesson 21. Okay? Now, the other thing that we got to review, for those of you who were on the religion retreat yesterday, okay, is what the mole is. Okay? 1 mole is 6.02 times 10 to the 23 particles of any given material. Okay, so if I have 1 mole of iron, I have 6.02 times 10 to the 23 atoms of iron. If I have 1 mole of water, I have 6.02 times 10 to the 23 molecules of water, because a molecule is the smallest unit of water, right? It's H2O. But for iron, iron is an element. Its smallest particle is an atom. All right, everybody follow me there? So if it's a compound, this is the number of molecules. If it's an element, it's the number of atoms. Okay? All right, so 1 mole of anything is this much. Okay? If I have 2 moles of something, how much do I have? Times 2, right? This number times 2. Okay, if I have 2 moles of something, I have twice that much. If I have 3 moles, 3 times that much. If I have 5.658, I have 5.658 times that much. Okay, that's 1 mole. Okay, the example we used yesterday, a mole is like a dozen. It always represents the same number. Okay, it doesn't matter what you have. If you have a dozen of something, you have how many? You have 12. Okay, if it's donuts, if it's eggs, if it's oranges, whatever, it's always 12. Well, it doesn't matter what I have. If I have a mole of it, I have this many. Okay? Is that a big number? It's a gigantic number. Okay? Remember, this is 602 with 21 zeros behind it. Okay? Atoms are small. Very, very small. And so, a small amount of something has lots and lots of atoms or molecules in it. Yesterday we used the example of water. Okay? In 18 milliliters of water, it's roughly the amount that's in this cup here, not very much. Okay? There are 6.02 times 10 to the 23 molecules of water in that glass. Okay? It's a lot. Okay? Molecules are very, very small. Okay, so quick review here. We'll go over, okay, we went over how to solve the 4 kinds of mole equation problems that you could encounter in this class. So what I want you to do right now is write these examples down with sufficient room between them to solve them. All right, so let's say maybe get 3 on a page at the most, okay? Leave a lot of room in between for all the work that's going to have to be done there. All right, so copy these ones down. Okay, and, This is what we did yesterday. I already said that. Okay? Okay, so we'll look over, okay, how we go about solving these problems. And that's not the one I want. Okay, so the first one is, how many moles of carbon dioxide are there in 150 grams? All right, so first thing we want to do here is erase what I have down so that you're not distracted by it ahead of time. Okay, first thing we do is write down what the question gave us. Okay, the question said, we're looking for how many moles? Well, N is the number of moles. I don't know what that is. That's what the question asked me for. Okay, but it did tell me that I was dealing with carbon dioxide. So I can calculate carbon dioxide's molar mass. That is, how much mass 6.02 times 10 to the 23 molecules of carbon dioxide have. All right? I do that by taking the masses from the periodic table. All right? And I look up carbon. Okay? 1 mole, or 6.02 times 10 to the 23 atoms of carbon, have a mass of 12.01 grams. Okay, so that's what I start with. Okay, 12.01 grams per mole. That's my carbons. How many oxygens are there? Right, 2. So I have to take the mass of 1 mole of oxygen, which is 16, okay, and add that to this. That will give me the molar mass. Okay, I just put in the numbers and I multiply them by however much there is in the compound. 1 carbon, 2 oxygens. Okay, so we got 12.01 plus 32 is going to give us 44.01 grams per mole. Okay, so now I have big M. The other thing the question asks, or gives me, sorry, is the mass. 150 grams. N is the number of moles. No. M, the 44, is the mass of 1 mole. N is the number of moles. We haven't calculated that yet. Okay? All right, so the mole equation looks like this. N equals little m over big M. I'm looking for N, so I don't have to do anything with this equation. It's already set up, okay, to do what I want it to do. So M, little m, was 150 grams, okay, and I divide that by the mass of 1 mole, 44.01 grams per mole. Okay, when I do that, okay, I'll get my final answer. All right, so that means I have 3.4 moles, or 3.41 moles of carbon dioxide. Nearest hundredth. Let's say 2 decimal places. Yeah. Okay, that's as easy as they come. Okay, so the big thing is to remember what each part of the equation stands for. N is the number of moles. Little m is the mass, always in grams. Big M is the mass of 1 mole, or the molar mass, okay, which you get from the periodic table. True. Question? Wait till we're done the examples. And then. Okay, you can use your phone if you want to. It's an iPhone, right? Oh, okay. All right, so next one here. Okay, so in the second one, they're asking us what's the mass of 26.5 moles of cobalt-2 bromide. All right, so what did the question give me? It gave me moles. Which letter stands for moles? N, right. So N is 26.5 moles. Okay? That's what they tell me first. Next thing is they tell me what the compound is. With that, I can calculate the molar mass. Now, as I said yesterday, don't expect on a quiz or a test to be given the formula. I will probably write the name in words, okay, which means you'll have to write the formulas properly, okay, swapped and dropped or whatever. All right, so cobalt. How many cobalts in that compound? 1. All right, so cobalt has a mass of 58.93. Okay, and it is attached to 2 bromines. Bromine is 79.90, and there are 2 of them. Okay, so I multiply it by 2. That will give me the molar mass of this stuff. Okay, so 58.93 plus 79.9 times 2, 218.73. Okay, grams per mole, because this is the mass of 1 mole. Okay, grams per mole. Okay, it's asking me what's the mass. So we're looking for little m. So we go back to our formula. N equals little m over big M. I need to solve for little m. What do I do? Right, okay, multiply both sides by big M. Okay? Rules of algebra are simple. Right? If you want to move something, you do the opposite of whatever it is you are already doing. So if I was dividing by M, to move it, I multiply both sides by M. Okay? All right, so now my formula is big M times N gives me little m. So now I can plug in my numbers. Okay, I have 218.73 multiplied by 26.5. Okay, it gives me 5,796.35. grams. Okay, so almost 6 kilograms worth of that stuff. That's quite a bit. Okay, everybody with me so far? All right, so those are the two easy ones. Okay, the other two have one more step. It's not that they're like brutally hard. They just have one more step. Okay, in this extra step, what we have to remember is this number. We haven't used it yet in the first two. Okay, this number is Avogadro's number. Okay, the guy who looked like a mole, right? Okay, we showed yesterday. If you weren't here, you missed out looking at a guy who looked like a mole. Okay, this is Avogadro's number. It is the number of particles in 1 mole. Okay. All right, so number 3 is asking me how many molecules of sodium sulfide are there in 29 grams? Okay, Dominic, can I have you shut that door for me? All right, again, first step, write down what the question gave me. The question asked me for how many molecules, but it tells me what material. So right away, I can calculate big M because I know what I'm dealing with. Okay, sodium sulfide, the mass of sodium, molar mass of sodium, 22.99. What do I have to multiply that by? 2, because there are 2 sodiums in this compound. All right, and then I got to add it to sulfur, which is 32.07. Okay. So 22.99 times 2 plus 32.07 gives us 78.05. grams per mole. Okay, the other thing they tell me, they give me a number in grams. That's little m. Any number in grams is going to be little m. Okay, 29 grams. All right, with those two things, what can I calculate? Number of moles. Okay, I can use the mole equation with little m and big M to get the number of moles. Is that what the question asked me for? No, the question asked me for the number of molecules. That's okay. If I want to calculate the number of molecules, I need the number of moles because I know how many molecules there are in 1 mole. Okay, it's just like this. If I ask you how many eggs there are in 4 dozen, you know it's how many? 48. How'd you know that? Because you went 4 times the number in a dozen, which is 12. So if I find the number of moles and multiply that by the number in a mole, I should know the number of particles. Agreed? Okay, so that's how it's going to work. So first I'll find N. Right, we'll have our 29 grams over 78.05. So obviously we have less than a mole here. Okay, that's all right. 29 divided by 78.05. Okay, so 0.372 we'll say. So we have 0.372 moles. In every mole, there are 6.02 times 10 to the 23. So if I multiply that by N, that gives me the number of particles. In this case, it's the number of molecules. All right, so we have 6.02 times that number. Now, in your calculator, showed this yesterday as well, if you're going to use this number, 6.02 times 10 to the 23, okay, you have to enclose it in brackets. If you don't, your calculator goes wonky and tries to do order of operations. You don't want it to do that. Okay, 6.02, okay, and then you hit the second function and the comma, because above the comma are two capital E's. Ironically, when you press that button, you only get one E, but that's all we want. Okay, that E means times 10 to the power of whatever I enter next, 23. Right? If you don't have a TI-83, the button you're looking for is either two capital letter E's or EXP. Okay, if you have an EXP button, it's the same thing. All right, so you'd go 6.02 EXP 23. All right, again, enclosed in brackets. All right, when I do that, I get 2.24 times 10 to the 23 molecules. Okay, so that's how we would solve that type of question. There's only 4 ways I can ask you a mole equation question. Okay, I showed all 4 yesterday. I'm showing another 4 today. All right, after today, you will have 2 examples of every way I can ask a mole equation question. I'll even do the same thing tomorrow. Okay, you'll have 3 examples of every way I can ask. All right. All right, 4th question. All right, it's asking me, what's the mass of 7.2 times 10 to the 23 molecules of diphosphorus pentaoxide? So in this question, it gives me the number of particles. Okay, it gives me the number of molecules. All right, so that's a little bit different than the last question where I was looking for it. All right, so one of my givens is the number of molecules. Okay, the other thing I'm given is what material I'm dealing with, P2O5. So that's going to be 30.97 times 2. Is that right? That's for phosphorus, 30.97. Okay, plus 5 oxygens, 16 times 5. All right, so 141.94 is our big M. Okay, how am I going to find the mass? Mass, if I'm going to find little m, I need this, which I have, and I need that. And I don't have that. I don't have n. So let me ask you this. You have 36 donuts. How many dozen do you have? 3. How'd you figure that out? You divided them. You took the number you had and divided by how many there are in a dozen. And you figured out how many dozen you had. Can I do the same thing here? I know how many molecules I have, 7.2 times 10 to the 23. And I know how many there are in 1 mole. So if I divide those 2 numbers, will I get the number of moles? Yes, in the same way that you just did the dozen calculation. All right, so that's the first thing I need to do. N is going to equal 7.2 times 10 to the 23 over Avogadro's number, 6.02 times 10 to the 23. So in brackets, 7.2 E 23 n bracket divided by Avogadro's number. Same thing, enclosed in brackets. Okay, gives me, let's say 1.2. Okay, we'll round it to 1.2 moles. Okay, so now I know n. Since I know n and big M, I can now calculate little m. All right, so little m is n times big M. 1.2 times 141.94. All Alright, so the mass of that stuff is 169.76 grams. Okay, that's the only 4 ways I can ask you a mole equation question. Everybody with me there? Alright, so like I say, if you were not in class yesterday because you're at the religion retreat, you got to find some time, okay, to watch that podcast, okay, quickly. Right? You don't necessarily now have to watch the examples because you've seen 4 examples, but you should watch the preamble. That's the stuff I don't really have time to go over again. Okay? Also, if you weren't here yesterday, you need to go get the worksheet from the 3rd drawer in that drawer unit under that little palm plant there. Okay? That's what you are working on for the rest of the day. Okay? Okay. Let's have a quick look here. Yesterday we talked about the first question just a little bit, okay? But I can see already a few people are confused by it because they're trying to do this for the first question, okay? Is this question asking you to find moles or mass? No. It's asking you to find the number of molecules. In order to do that, you have to use Avogadro's number. This one. 6.02 times 10 to the 23. Remember, that number is the number of atoms, molecules, particles in 1 mole. So, how many atoms of gold, question 1a, how many atoms of gold are there in 1 mole? Say it. 6.02 times 10 to the 23. 1 times 6.02 times 10 to the 23, right? Okay, it says there's 1 mole. This is how many there are in 1 mole. Okay, how many are there in 2.5 moles? Exactly, 2.5 times Avogadro's number, and you've got the answer. Okay, it's the same for C. 10 times Avogadro's number for D. Number times Avogadro's number. All right, you'll get to using n equals little m over big M when you get to number 2. Right, then you'll start using the mole equation for that one. All right. Now, the key for this, okay, is on my website because obviously the answers aren't on that first sheet. Okay, so if you go to my website here, okay, Science 10 Notes and Assignments, Chemistry, and keys to all mole equation worksheets right down here at the bottom. Okay, keys to all mole equation worksheets. That's the one you want. Okay, it is unfortunately a scanned version of my chicken scratch. Okay, but I think you'll be able to figure it all out. Okay, so you can check them there as you go. Your reactions assignment, those 30 questions, is due tomorrow. All right, so make sure you get that done tonight. That's your homework tonight. Okay, you do not want to take late marks on that thing. All right, so make sure you get it done tonight so it is ready to hand in tomorrow.